In this video, we're going to look at the use and care of the pH probe. The first thing you'll notice about the pH probes is that they are kept in between laboratory periods in a storage solution. This solution is a carefully prepared solution for long-term storage. Our first job will be to remove the pH probe from the storage solution, which will mean you'll have to unscrew the vial top and pull out the pH probe. Now, the pH probe in this way is a fragile device, although you'll notice a blue plastic cover over the entire length of the pH probe. The end is actually glass and exposed. It's very important that you're aware of this glass tip, as it's quite fragile and easy to break. Before we use the pH probe, we're actually going to push up on the top. This screw lid that was originally attached to the storage solution needs to be pushed up further along the length of the pH probe so that we can extend the reach of the pH probe. That is, we'll be able to reach into solutions better with this lid pushed up into the upper position. And so here you can actually see the lid has been pushed up to a higher position. When you're not using the pH probe, say in between measurements, it's important to put the pH probe in a beaker of distilled water. You'll notice in this diagram the pH probe is actually held by the articulated arm, which is where it will be for most of the time that you are using it, except when calibrating, and we'll get to that in just a moment. I'd also like to point out that the pH at this point is probably not going to be equal to 7. And the reason for that is that there's actually a large amount of carbon dioxide in the atmosphere, as you know, and some of this carbon dioxide winds up dissolving in the distilled water, that's the storage solution, and converts over into carbonic acid, H2CO3. The presence of this carbonic acid gives us a pH which is actually less than 7, and you shouldn't be surprised if that's what you observe. Now, to just jump ahead a little bit, if you're finished at the end of the day, what you need to do is you need to return the pH probe back to the storage solution. That's going to mean having to take the lid, which is currently in this position, and to carefully push it down to approximately the same place it was when you first began. This is very important because in its extended position, the pH probe, when put into the storage solution, can actually crash into the bottom of the storage solution vial. Doing this will likely break the end off the pH probe. These are not repairable, and so the pH probe would be ruined. And so as you're pushing this, as you're reinserting the pH probe into the storage solution, be very aware of the fragile tip at the end, and remember that the pH probe, when it's actually in the storage solution, should not come into contact with the bottom of the vial, so there should be no contact at this point. Be very careful with this, and please don't simply push the pH probe into the storage solution down to the bottom and then attempt to push the lid into its correct position. The screw lid for the storage solution should always be adjusted before the pH probe is put into the storage solution vial. During use, it's important to treat the pH probe correctly, as well as to minimize the possibility of cross-contamination between measurements. And so between uses, it's quite important to first rinse the pH probe with a stream of distilled water. Have a waste beaker handy because you'll want that distilled water to fall into something. And then use a piece of tissue to gently blot or dab at the bottom of the pH probe to remove any excess moisture that might be still clinging there. It is not necessary to scrub the end of the pH probe, just simply to rinse with distilled water and gently blot, and then as need be, you can return it to the storage solution that you had prepared before. Again, this is to keep the pH probe properly rinsed and to minimize the chances of cross-contamination. Now, the pH probes right out of the drawer will not read accurately. They do need to be calibrated, and we're going to be calibrating the pH probes today using two different buffers of known pH. The first buffer is going to be a pH 2 buffer solution, and the second buffer is going to be a pH 12 buffer solution. The reason we're using such broad-spaced pHs for calibration purposes is because we would like the pH probe to be accurate over a fairly broad range, as the pHs that we're going to measure today will be both acidic and quite basic. We're going to go for the broadest calibration possible, although truth be told, if you were really interested in accurate pH measurements, you would certainly calibrate it over a tighter range. But this broad range will suffice for us here today. Referring to the Vernier software, what you'll need to do is first click on Experiment, then look for the Calibrate menu. Springing off to the side will be the pH probe, and then once the menu opens, you're going to want to click on Perform Now. This will initiate the calibration, at which point what you're going to want to do is you're going to want to take the pH probe and immerse it in the first calibration solution. Okay, so you'll take the top off that pH 2 buffer and you will insert the pH probe directly into the vial, and then it's important that you also stir, and the only way to really stir is to move in an up and down direction to keep fresh solution passing by the pH probe. All right. Typically, it's necessary to wait approximately 10 seconds before accepting this particular value. What we're doing here is we're showing the computer what a pH 2 actually looks like, and then it will use this as part of the calibration, but it'll need a second point that we'll get to in a second. Another thing to mention is that the large pH display that you'll see in the background will not be active during the calibration process. And so don't expect to see any changes to that large pH display as you are doing the calibration. That large display will become active again when you finally complete the calibration. Okay, so when you finally waited about 10 seconds or so and things seem to be settled down, the next thing that you do is you click Keep. And this will help tell the computer to memorize that particular pH 2 buffer response. Now, the next thing that we have to do is complete the 2-point calibration by taking the pH probe at this point and moving it on to the pH 12 buffer solution. So we immerse it directly into the buffer solution with the pH 12, and then again we do the same sort of thing. We stir using an up and down motion to make sure that there's fresh solution passing over the tip of the pH probe. After waiting about 10 seconds or so, and again remember that large display in the back is not in the background is not going to be active during this time, what you'll do is you will click Keep. And then finally, it's necessary to finish the calibration by clicking the Done button. Now, once the calibration has been finished, the large display in the background will again become active and measure, and it will indicate the pH that the pH probe is measuring. So at this point, it's a pretty good idea to check the calibration. This is easily done by simply taking the pH probe and moving it from the pH 2 buffer to the pH 12 buffer, remembering to rinse in between, and just check to make sure that the pHs indicated on the screen of the computer are reasonably close to 2 and 12 respectively. Your instructor may also have a pH 7 buffer that you can use to check the calibration of the pH probe. Your pH probe should read something very close to 7 when this solution is checked. However, the pH 7 buffer is not used for calibration purposes.